Welcome to section 3.2 about theorems. We are not going to get into those theorems in this video or even the next one, but in order to use those theorems, we do need to understand how to long divide polynomials. So before we get into doing long division with polynomials, I want to just talk about long division as a whole. All right, I do have one example. Let's say we wanted to take 584 and we wanted to divide it by 23. All right, yes, you could do this on your calculator, but it would give you some decimal, meaning 23, doesn't fit into 584 evenly. It's not a factor of 583. But let's do this using long division so we can find that remainder. So I know this is probably taking you back to elementary school a little bit, or maybe middle school. So we'll set it up just like this. And I'm not going to super get into the vocab, but this is called the dividend in here. And on the outside, this is the divisor. That's what we're dividing by. Our answer will be our quotient, and we'll also have a remainder at the top. All right, so the first thing we want to do is see how many times does 23 fit into 5? None. I'm not going to put a 0 up here because when we write numbers, we don't usually put a 0 in front of them. How many times does 23 fit into 58? 23 fits into 58 2 times, so I'm going to put a 2 up top. Then our next step is we'll take this 2 times the 23 and we'll write it down here. So 2 times 23 is 46. Then we subtract. I'm only doing 58 minus 46. I'm not dealing with this 4 over here yet. So we'll do 8 minus 6 and 5 minus 4. The subtraction is not too bad. We'll get 12. All right, 23 can't fit into 12. It shouldn't be able to. So then next we bring the 4 down. So we bring this 4 down. We're going to fill in the spot that's above the 4. All right, so now we have the number 124. We want to see how many times does 23 fit into 124. I know that 23 fits into 100. It's close to 25, right? It fits into 100 4 times, and then it'll fit in an extra time. So I know that it's going to fit in 5 times. And then off to the side, we can just do a real quick 23 times 5, since that's our next step. So when we do that, we'll get 15 and then 11. Okay, so that's 115 down here. We'll subtract. I can't do 4 minus 5, right? So, whoops. So we put the 1 there, and then we borrow here. All right, so we do 14 minus 5, which is 9, and then 1 minus 1, 1 minus 1. So our remainder is 9. So here's what this means. This means that 23 fits into 584 25 full times. And then there's an extra 9, a remainder of 9. So that means we can rewrite 584, our dividend. We can rewrite 584 as the product of our quotient, 25, times that divisor, 23, and then we had an extra at the end, an extra 9. So 23 fits into 584 25 times, so 23 times 25, and then there was an extra 9 as a remainder because 23 is not a factor of 584. It doesn't fit in evenly with a remainder of 0. All right, so that's just a quick recap of long division. Polynomial long division follows the same general format. There's some slight differences. Let's get into some examples with polynomial long division. In this first example, we want to take this cubic polynomial and divide it by this linear binomial here, x minus 2. Now, this looks very similar to the problem we just did of general long division, so we're going to set it up in the same way. I'm going to set it up with our division here, and we have our divisor, x minus 2, out in front, and we have our dividend on the inside. Now, the dividend is the larger polynomial, right, that we're dividing into. And we want to make sure that there's no missing terms, meaning we start with our cubic term, then the next term should be the quadratic term. It is, right? The next term should be the linear term. It is. And the next term should be the constant, meaning our exponents don't skip at all. They go from 3 to 1 and then an exponent of 0. That's just the constant. If there is a skip, if we're missing a term, we do have to put a placeholder of 0, and we'll see that in the next example. But we don't need any placeholders here. So under our division bar, I guess, I don't know if this has an official name, X cubed plus 4x squared minus 5x minus 14. And then we're just going to get into the division, so let's start. All right, our first step is we want to go one term at a time. We're going to start with the x. So we're going to do x times what fits into x cubed, right? How many times does x go into x cubed? So x times what gives us x cubed? That answer is x squared. We're going to put an x squared up top. And then, just like before, our next step is multiplication. So we're going to multiply the x squared times the x minus 2. So 2 multiplications. We're going to do x squared times x, which it gets us back to x cubed. That should cancel. And then we're going to do x squared times a minus 2. X squared times minus 2, or negative 2, gives us minus 2x squared, which we're going to write there. So minus 2x squared. Our next step is subtraction. So we're subtracting more than one term, so we put a minus sign around it. Now, let's be careful here with subtracting negatives. We'll get there in a second. This is x cubed minus x cubed. There's 0 x cubes here, which I'm not going to write. Then we have 4x squared minus negative 2x squared. So it's 4x squared plus 2x squared. So that gives us a 6x squared. Great. The next thing we're going to do is bring down the next term, which is minus 5x. Now, some people like to bring down the whole thing every time. That's completely up to you. Like some people will bring down the minus 14. I just like to bring it down one by one, but that's completely up to you. It's no harm if you bring that down as well. It's not going to be used in this next step anyway. All right, then we're going to repeat the process. So we're going to say x times what will get us into 6x squared. All right, so x times what multiplies to give us 6x squared? 6x. So we're going to put a plus 6x up here. Then we're going to multiply the 6x through our divisor. 6x times x gets us back to 6x squared, and it should. We want those to cancel eventually. Then 6x times minus 2 is minus 12x, which we'll write there. I wanted to do that in white. So minus 12x. Okay, then we subtract. Okay, when we subtract, we're doing 6x squared minus 6x squared. That cancels. Then we're doing negative 5x plus 12x. So that gives us 7x. Then we bring down the minus 14 and we repeat our process again. All right, so x times what gets us to 7x? That's a positive 7. Then we multiply the 7 through by our divisor. 7 times x is 7x. 7 times minus 2 is a minus or negative 14. However you want to, if you want to say it as minus or negative, they're basically the same thing. All right, then we're subtracting something by itself, so our output ends up being a 0. That means we do not have a remainder. That's not RO, that's remainder 0. And yes, I do still write remainders just with an R. I know it's like pretty elementary, but I just think it's easiest to look at. But that means that x minus 2 fits perfectly in to this guy right here. So let's write our final answer. Let's write our polynomial. So our original polynomial is this. So how can we rewrite that polynomial? We found that our original polynomial, p of x, this guy, so x cubed plus 4x squared minus 5x minus 14, can be written as the product of two polynomials. When we divided it by x minus 2, we got this guy out. So the opposite of division is multiplication. So if we were to multiply x minus 2 by this quadratic trinomial up here in yellow, we get back to our original polynomial. There was no remainder, so these two multiplied together gets us back here. So we can write it as the product of the quotient that we got, x squared plus 6x plus 7, times our original divisor, x minus 2. Now, at the very end, we totally can put plus 0. It's not really necessary in this case. You know, in math, we don't need to write a plus 0. But if there was an actual remainder there that wasn't 0, it would matter. So anyway, we just did polynomial long division by our polynomial p of x divided by our divisor, which we will call d of x. I'm going to get more into this notation in just a little bit. And we got our quotient, q of x. The remainder will eventually be called r of x, but in this case we don't have one. So anyway, we did polynomial long division, and we can rewrite our final answer of division as multiplication. Here's our second example of polynomial long division. We can see here that we have a quintic trinomial, and we're dividing it by a linear binomial. Our quintic trinomial here is missing the x to the fourth term, and it's missing the x squared term, and it's missing the constant at the end. So this is a good example of showing how to set that one up when you're missing some terms. So I'm going to set this up as we'll have x plus 1, our divisor, and then our dividend in here. I'm going to need to extend this. This is negative x to the fifth plus 0x to the fourth plus 7x cubed plus 0x squared minus x, or 1x, plus 0. So we needed all these placeholders. I guess you could argue that you don't necessarily need this one, but I just like to put it there so we can finish it out nice. But you definitely need the ones where you have terms on either side. So we needed these placeholders again when you're like skipping or missing one of the terms. Look, we go from 5 to 3 to 1 in our exponent, so we're missing 4 and 2, and the constant at the end. Okay, let's go through the same process. I'm going to move a little quicker because we've already talked about the process. So x times what gives us negative x to the fifth. That answer is negative x to the fourth. Then we're going to multiply negative x to the fourth through our divisor. So negative x to the fourth times x gives us negative x to the fifth. It should be the same term as above it. Negative x to the fourth times 1 is minus, you can put minus 1 if you want, x to the fourth. Then we subtract. The first term cancels. The second one, we have 0x to the fourths minus a negative 1x to the fourth. So that's a 1x to the fourth there. Then I'm going to bring down, and I wanted to do that in turquoise. That's a 1x to the fourth. Okay, then we bring down our next term, which is plus 7x cubed. And we repeat, we repeat our process there. That's a 3. Okay, then let's see. X times what will give us x to the fourth, and that answer is x cubed. Then we multiply through by the x cubed times x, and then x cubed times 1. So x cubed times x is x to the fourth. X cubed times 1 is plus 1x cubed, and then we subtract. Our first terms cancel, and this is 7x cubed minus 1x cubed, so it's 6x cubed. Then we bring down our next term, and we just keep going. X times what will get us 6x cubed. 6x squared is the answer. Then we multiply 6x squared through the divisor. 6x squared times x, and then 6x squared times 1. 6x squared times x is 6x cubed. 6x squared times 1 is plus 6x squared. And then, of course, we subtract. So we'll be left with negative 6x squared. And then we bring down the negative x. Okay, our next step, we want to see same thing. So we're repeating the process again. X times what gives us negative 6x squared. The answer is negative 6x. Then we multiply negative 6x through the divisor over here, distribute it through, and write it under here. I need to make this all a little bit smaller. Oops. There we go. Okay, when we multiply through, we'll get negative 6x squared and then we'll get negative 6x times 1 is negative 6x, and then we're distributing a minus sign, aka subtracting. So we have, this cancels, negative 1x minus a negative. So negative 1x plus 6x is 5x. This is a long problem. Okay, then we bring down the plus 0. All right, we repeat our process hopefully one more time. X times what? Sorry, x times what is 5x? A plus 5. So we distribute the 5 through, so we'll do 5 times x, which is 5x, and then 5 times 1, which is plus 5, so minus. Then we subtract, so we'll get negative 5, and that is our remainder. I know that's our remainder because I can't repeat the process again. Like I can't do x times something to just get negative 5, not anything that's a polynomial. So anyway, so that's our remainder. All right, remainder negative 5. And then I want to write our final answer as like a multiplication problem. All right, so here's how I'm going to write my final answer. This is the way I'm going to write it. So I'm going to write it as p of x, the original polynomial, is going to equal d of x, our divisor, times q of x, our quotient, plus our remainder. So this is the original polynomial, OG. This is the divisor, what you're dividing by. This is the quotient. The quotient is your answer. And then this guy is the remainder. Okay, so we took our original polynomial, which is negative x to the 5th. I don't need all the zeros, plus 7x cubed minus x. And then we divided it by x plus 1. And then we got this answer. We got negative x to the 4th plus x cubed. This is what we got on top. Plus 6x squared minus 6x plus 5. Whew. And then it wasn't just this times this that got us back to the original polynomial because we had a remainder. So we still have to have plus a negative 5 at the end, or just a minus 5. So we divided this OG polynomial, p of x, by x plus 1 and got this out. So that means x plus 1 times this giant thing here, this giant quartic polynomial, multiply together. But then we also at the end have to subtract 5 or add that remainder in to get back to this. So if you really wanted to do this, you could multiply all the way through, multiply the x all the way through, multiply the 1 all the way through, combine all the like terms, and then put a minus 5, and you'll get back to this original guy here. So that is always a check that you can perform. So to check division, you can do multiplication. Pretty cool. This is the last thing I want to just show you. I just wrote this up. When you're asked to divide some polynomial divided by another polynomial, p of x divided by d of x, this is how you set it up. The larger polynomial is on the inside. It is, well, it's called the dividend, but I'm just calling it the OG polynomial, but you could also call it the dividend. Anyway, this one on the outside is the divisor. That's what we're dividing by. The answer that we get is the quotient, and technically the remainder is part of the overall answer, so I don't love that it's like a separate thing, but we add it on at the end. Anyway, so if you're asked to write your answer in this form, that's all that means. You're just rewriting the division using multiplication. So I would get this written down in your notes. You're asked to do this up here. This is how you set it up in white and blue. Your answer is, the quotient and the remainder in yellow and black up top. And then this is how you can write your final answer. So it's color-coded. I would definitely make sure you have that in your notes. And there you have it, some polynomial long division. Hope you had fun.